Okay, I'm giving you a short lesson on probabilities involving area. So imagine for a moment that we are randomly dropping pennies onto this mat. And let's say it's a 10 by 8 mat. Let's say it's in inches. So first of all, the total area over which it could land, all the possibilities you might say, would be 10 times 8 is 80 square inches. That's all my possibilities. Now, what if I secretly, so the person didn't aim at it, had marked off this territory, which was a little circle off to the side, and said, what's the probability that my penny will land in that little zone? So let's say that its radius is 2. And now I've got to figure out what's the probability that my penny will land in this little shaded region that's a circle. So my area on the top is going to be pi r squared for my little circle. My radius is 2, so then it's going to be pi times 2 squared. 2 squared is 4, so that's going to be 4 pi. And 4 pi over 80 is my total. It's what I wanted to happen over what's possible. And so it's your favorable outcomes on the top divided by your possibles on the bottom. Now, this also should be inches squared, and then my denominator, my units can cancel. And if you wanted to get a decimal for it, you'd have to use pi, which means you'd have to make this a little less exact because you're going to have to put in a decimal, 3.14, which is close to pi, but it's actually rounded. So the answer would be a little less accurate, but you could say 4 times 3.14, and then divide that all by 80 and get a decimal for the probability. All right, so imagine I have a similar situation, except it's got, let's make it a little more complicated. A half circle here that has a radius of 3. And let's say I have a triangle down here, which has a base of 3 and a height of 4. And they say, what's the probability that it lands in the triangle or the half circle, the shaded region? All right, well, I need to know my total. Let's say that this distance from here to here is 9. And if it was already 4 to here, let's say it's another 3 from here to here. So this total side is 7, and this total side is 12. So the area of the whole thing, everything that's possible, would be 12 times 7, which would be 70, 84. And let's keep it in inches squared. And then the area that I want, the things that are favorable outcomes for me, would be the area of these two things. Well, first of all, a triangle's area is 1/2 base times height. Well, the base here is 3. Base times height would be 3 times 4 is 12, and half of that would make 6. So the area of that is 6 square inches. And the area of my circle is based on pi r squared, but I only have half of the circle. So my formula is going to be 1/2 of pi r squared. My r squared, my r is 3. So 3 squared will be 9, so I'm 1/2 of pi times 9. And then I could say 9 is, half of 9 is 4.5, so it's 4.5 pi. So my final answer for this one would be to find the probability of landing in the shaded region. I would go 4.5 pi for the circle, plus the area of the triangle was 6, and those are all both in square inches, so my denominators units will cancel too. And here's my answer. It's not very elegant, but if I wanted to get it all as a decimal, I just have to substitute in 3.14 right there. 4.5 times 3.14 plus the 6 all over 84. These are the things that made me win this or this. When you have an or like that, you would add the probabilities together, all over 84. So there's a couple examples of area in a probability problem. So take care.